welcome to my class. In today's class, we'll be talking about theory of logarithm, meaning we'll be breaking down logarithm, right? So without further ado, don't forget to like, share, and subscribe so as to get notified whenever we drop amazing contents like this. Without further ado, let us get started. Now, there's something you need to know again about logarithm. Logarithm is actually quite similar with indices. Let me explain. Normally, when we have 8 is equal to 2 raised to power 3. Of course, 2 raised to power 3 is 8, right? That means 2 multiplied in 3 places. Alright? So, then we have 8 is equal to 2 raised to power 3. This, you see 2 raised to power 3. This 3 is called the power or the exponent, while this 2 is called the base. Now, the same thing for logarithm. Look at this equation we have. We can change it to a logarithmic equation. As for the base, for the initial equation where we have 8 is equal to 2 raised to power 3, this 2 here is the base, alright? So when we change this to a logarithmic function, then we have this base 2 comes here. We have log 8 base 2 equals 3. Alright? So that's it. We've just changed this initial equation to what? Logarithmic equation. And now, as for logarithm, the common base, like the static base for any logarithmic function, a function whereby the base is not indicated. If I have log of base 8, so now this is a logarithmic function, right? But the base is not indicated. The base is omitted. Once the base is omitted, just know that the base is what? Base 8. Alright? So if I were to write 1 is equal to 10 raised to power 0, 10 is the base. This 10 comes here. We have log 1 base 10 is equal to 0, which could be log 1 is equal to 0. Because we know that omitted base here is still base 10. So let's take some examples on that so as to understand more on logarithms. So let's start. First example, example 1. So firstly, let us take the first question. Here is the first question. Log 0.0625 base 4. We have to solve this without the use of calculators. Alright, so here is the first thing you do. When you have something like this, we have to express it, right? We have to solve it, to evaluate it. So the first thing we do here is we equalize it to an unknown. So solution to this first question. We equalize it to an unknown. It can be x. Now let's use x. So now we want to solve this. Now we equalize it to an unknown value, which is what? X. So following the normal way, saying what? This base here now, it moves to the other side. We are looking for the unknown. This base moves to the other side. So we have 0.0625 is equal to 4 raised to power x. The power here is unknown, but we have a base. That means we want to equalize this base so as to eliminate. So at this point we round it backwards. 1, 2, 3, 4. So we say 625 over the amount of zeros that was counted. 1, 2, 3, 4, which is 625 over 10,000. 625 goes there 1, 625 goes there 16. We have 1 over 16 is equal to 4 raised to power x. Knowing that 16 is what? 4 raised to power 2. That's 1 over 4 raised to power 2 is equal to 4 raised to power x. 1 over 4 raised to power 2, that is 4 raised to power minus 2 is equal to 4 raised to power x. Cancel, cancel. X is equal to minus 2. So that is the final answer for that. Okay? Okay, moving to the next example, which is the example 2. So, moving to the next example. This is the first method of solving something like this. For the second one, we have log 0.25. Now we change everything is here to a fraction. 0.25 we change that to a fraction, that is 25 over 100. 128 is 2 raised to power what? 7. We want to equalize the bases. 25 over 100, now we say 25 goes here 1, 25 goes in 100 4. That's log 1 over 4 2 raised to power 7. So 1 over 4 is 2 raised to power, as 1 over 2 raised to power 2, 2 raised to power 7. So that's log 2 raised to power minus 2, which is 1 over 2 raised to power 2, 2 raised to power 7. This is log 2 base 2. It cancels each other. Then we are left with 7 over minus 2, which is minus 7 over 2. That is the final answer. So now let's move to the next example, the third example. So we have log 0.5 base 32. The normal way to do it, like saying what? You equalize it to an unknown. Now let's equalize it to an unknown, meaning let's equalize it to, let's say, y. So the base comes here now. So we have 0.5 is equal to 32 raised to power y. 0.5 here is 5 over 10 is equal to 32 raised to power y. 5 goes here 1, 5 goes here 2. 1 over 2 is equal to 32 raised to power y. 1 over 2 now, when you change it to an initial number, we have 2 raised to power minus 1. And 32 here is 2 raised to power what? 5. Right. This cancels this. Minus 1 is equal to 5y. Divide by 5 over 5. Y is equal to minus 1 over 5. And when solving questions like this, the best thing to do is to equalize it to an unknown. That is the best method. Now moving to the last question under that. D. Equalize it to an unknown. Let me use A. So this base comes here. We have 2 root 2 raised to power A is equal to root 128. They have different powers, but we need to what? Equalize the base. So that is 2 in the bracket 2 times root 2 is 2 raised to power half. Root is power half. This 2 here is 2 raised to power what? 1. A is equal to root, that is root 128 is 2 raised to power what? 7. In the long run, we have 2 raised to power. Multiplication here means addition of powers. 1 plus half. Get A. So it's equal to this root here. It affects everything here. Root means power half. Half times 7. That is 7 over 2. 1 plus half. That is 2 raised to power 1 and the half, right? Raised to power A is equal to 7 over 2. Is equal to 2 raised to power 7 over 2. We just want to have the same basis. Multiplication of powers according to the laws of indices, the third law of indices. When two powers are separated by brackets, they multiply each other. So we have 2 raised to power 1 and the half is equal to 2 raised to power 7. These two cancels 2. 1 whole number 1 over 2 changes to an improper fraction. So that is 3 over 2a is equal to 7 over 2. 2 cancels 2. Alright, so we have 3a is equal to 7 Divide both sides by 3/3. A is equal to 7/3. So that's the final answer for that. So now we'll be moving forward. Now when we'll be talking about the laws of logarithms. So welcome back. Moving to the laws of logarithms. Like I mentioned earlier, that logarithms are quite similar to indices, right? Logarithm has its own laws, while indices too has its own laws. But their laws are quite similar. Now let me explain that. For the laws of indices, now we are recalling the laws of indices. The first law, we have a raised to power m times a raised to power n, which is a raised to power m plus n. Multiplication in indices means what? Addition of powers, as long as they have the same basis. So for the second one, a raised to power m divided by a raised to power n, that is a raised to power m minus n. A raised to power m into brackets n, that is a raised to power m times n. A raised to power m. So that's that. Right? So now let's move to the laws of logarithm, because it is these laws that will guide us when solving questions. It breaks down the questions more. Once you understand the laws, you won't have problem. And don't forget, there's something you need to know again. If I write log 5 base 5, that is 1. Right? Log 2 base 2, something like that, that is 1. Because 2 is 2 raised to power 1. This cancels this. 1 is left. If I say log 2 base 1, no, sorry, log 1 base 2. Log 1 to the base of anything is 0. So, and why do I say that? That is log to the base 2. This one is can be 2 raised to power 0. Knowing that anything raised to power 0 is what? 1. This cancels this. That's 0. Obviously. So now let's take the laws of logarithm. Let's understand better on the laws of logarithm. Alright, so moving to these laws of logarithm, which is the main one. For the first law, mn here means what? M times n, which is what? Multiplication. And as for multiplication in logarithm, it is addition. Now we have a common base, base a. So when we want to express this, we express it as what? Log m base a plus log n base a. So that's it. Then for the second one, we have log to the base a m over n. They are dividing each other. Division in logarithm is subtraction. You just take the common basis. As for the third one, the base a, log m to the base a raised to power n. When you have a power in logarithm, the power moves back. So these are the things we apply when solving questions on logarithm. Let us take few examples on that. So let me take it here. Let's take a few examples on that. So starting with this first example, log 3 plus log 8. As said, addition in logarithm is multiplication. The bases here are not indicated, meaning the bases there should be what? Base 10. Alright? So we have log 3 times 8. That is log 24 to the base 10. As long as the base is omitted, that's base 10. As simple as that. So moving to the next one. 3/4 log 16. Now, in the third law I talked about, when we have a what power, it moves backward, right? Now, we can reverse it again. The main reason why we are reversing it is to solve this question. So this 3/4, it comes forward again. You can have log 16 raised to the power 3/4. The base is not indicated, meaning it's to the what? Base 10. That is log 16 raised to the power 3/4. 16 raised to the power 3/4. When a number is raised to the power of a fraction, the denominator serves as the root while the numerator serves as the power. Alright, so we have 4th root 16 raised to the power 3. 4th root of 16 is 2 raised to the power 3, and 2 raised to the power 3 is what? 8. So the final answer to that is log 8. Alright, now to the C question. So moving to the C question. So this question is a question from the third law of logarithm, following the third law. So 4 log 8 minus 5 log 4. Alright, so what we do here, this power, this number at the back moves forward and turns to the power, just like we talked about in this third law, just like something we did here. So we have log 8 raised to the power 4 minus log 4 raised to the power 5. The subtraction sign in logarithm is what? Division. So that is log 8 raised to the power 4 over 4 raised to the power 5. That is log 8 raised to the power 4, that is 8 multiplied in 4 places. 8 times 8 times 8 times 8. 4 raised to the power 5, 4 multiplied in 5 places, 4 times 4 times 4 times 4 times 4. That is log. 8 multiplied in 4 places, that is 4096. 4 multiplied in 5 places, that is 1024. This goes here, this goes here, 4. So the final answer to that is log 4. So that's the final answer. So for the fourth question, we have log a square over root a to the what? Base a. They are dividing each other. Following this law of logarithm, the division law, we follow exactly something like this. So they are dividing. We have log base a raised to the power 2 minus log to the base a root a. The first thing we do here, we take the common basis. So that's log a square base a minus log base a. Square root a means power half. Square root means power half. Log a base a is cancel each other. Log a base a cancel each other. We have 2 minus 1 over 2. So 2 minus 1 over 2, that is over 1. That should give us 4 minus us 3 over 2. That's the final answer. So as for the fourth question on that, which is the last question. So this is mainly division. But firstly, there are still things you need to note. They don't have bases, meaning the common base is what? Base 10. And as for 125 and 25, there's something common. That is, we have log 125 is what? 5 raised to the power 3 over 25 is what? 5 raised to the power 2. Square root here means power half. So we have log 5 raised to the power 3, and we still have the power half here. That is over 2. Alright? So meaning that power half, it multiplies this 3 all over log base log 5 raised to the power 2. These are the powers. So we have log 5 raised to the power 3 times half, 3 and a half, that is 3 over 2 over log 5 squared. Once the powers move to the back, this comes here, we have 3 over 2 log 5 over 2 log 5. Following the third law, I've explained that. This cancels this, so we have 3 over 2 divided by 2 is division sign. So we have 3 over 2. The division sign changes to multiplication sign, and we take the inverse of the fraction in front. That is times the inverse of 2 is what? 1 over 2. 3 times 1, 3 over 2 times 2 here now is what? 4. So that's the final answer. So now let's take the last example. We'll be moving to the third example. As for this third example, it's quite different from the ones we've been doing before, whereby we'll be getting exact values. But here, you'll be given the logarithm of some numbers, and you'll be asked to find the logarithm of other numbers with the previous number you were given. Now, like something like this now, we said log 2 base 10 is this, log 3 base 10, log 7 base 10. With the logarithm of these numbers we have, you are asked to find other numbers. So, solution to that question. So, log 108 base 10. You are given the log of 2, log 3, and log 7, and you are asked to find the log of 108. So, the first thing you look, we express 108 log to base 10. 108 should be 4 times 27. Multiplication now means what? Addition. So that is log to the log 4 base 10 plus log 27 base 10. So that is log to the base 10. 4 is what? 2 raised power 2 plus log 27 is what? 3 raised power 3. Following the initial third law, the power moves backward. We have 2 log 2 base 10 plus 3 log 3 base 10. That is 2. Log 2 base 10 is what? 0.3010. Log 3 base 10, 0.4771. So now we multiply and add. 2 times 0.3010, that is 0.6020 plus. The same thing we'll be doing for the next one. We just add the values. So 3 times 0.4771. So that should give us 2310, 2310, 2310. So that should be giving us 2313. That's 1.4313. All right, that's 1.4313. Then we add this to this. That's 2 points. Make sure the values are correct. 2.0333. So that's the answer. So we are giving decimals here. Here we are mainly dealing with addition of their decimals. So for the second example, that is log 13.5 is 135 over 10 is 10. 5 goes here 27, 5 goes here 2. That is log 27 over 2 base 10. They are dividing, that is log 27 minus log 2 base 10. So they have base 10, and as we've done here, log 27 is gave us what? 1.4313 minus log 2 base 10 now is what? 0.3010. If you could recall, it was the log 27 base 10 we got here that gave us 1.4313. Without stressing ourselves, we can easily know that this is the value. Then we subtract that immediately. So So after subtracting, we have 1.1303. So that's the final answer. 1.13013. That's that for that. Moving to the third example, mix fraction to improper fraction. That is 3 times 1, 3, 3 plus 1, that is 4 over 3. Which is 4 over 3. That is 4 over 3. This is under division. Alright? So that is, and division here means what? Subtraction. That is log 4 base 10 minus log 3 base 10. And 4 is what? 2 raised to the power 2 minus log 3 base 10. So the power comes here. We have 2 log 2 base 10 minus log 3 base 10. That is 2 into brackets. Log 2 base 10, which is 0.6020. Log 3 base 10, 0.4771. Right? So 2 times, okay, I've made a mistake. Log 2 base 10 here is 0.3010. So they multiply, that is 0.6020 minus 0.4771. You can easily subtract that 0.6020, 0.4771. So while you're at that, we have 5, 10, 9, 4, 2, 1. 0.1249. It's actually easy, just subtraction and addition of decimals. So for the 49, this is a decimal number. The first thing we do, we change the decimal to a fraction. 0.49, that's 49 over 100. And they are dividing. And division here means what? Subtraction. That is log 49 minus log 100. And it is to the base of what? 10. Because the base here is not indicated. Alright? So, we have log 49 is what? 7 raised to the power 2. 100 is 10 raised to the power 2. This cancels this, we are left with 2. The power 2 comes here, that is 2 log 7 base 10 minus 2. Log 7 base 10 as given is 0.8451 minus 2. So we move forward by saying 2 times 0.8451. When we multiply, we get 0.8451 times 2 plus 2, 0.19. Okay, that's 1.6902 minus 2, which is 2.00 minus 1.6902. 1 minus 1, which is 0. This is just normal subtraction we are doing here. It's 9, 9, 19, 9, 2, 8, 9, 0, 3. That's 0.3098. So that's that for today. And don't forget to like, share, and subscribe so as to get notified whenever we drop amazing contents like this. See you in the next class.